talk a little bit about fraud case and KYC and talk a little bit about Nyenrode Business University, where we teach artificial intelligence in the context of cybersecurity or digital security. We're talking with Enrique. It is it's a vertical and not an horizontal. So that's a nice concept also he brought in. This is me. I'm working for Nyenrode, Rabobank, and I have my own consulting firm. I started artificial intelligence somewhat in the 90s. I reached back to coding in the 80s, and I love robotics and I love things to do around that. This is the Nyenrode track we teach. We do at Nyenrode Modular MBA, so students come in from what we call mid-career positions and do a MBA or modular MBA. One of the modules is AI and digital security, AI Sec, and that's taught by me. So we placed artificial intelligence inside a container of looking at security and looking at these kinds of issues. That comes from my work from the Rabobank, where we do a lot of work on cybersecurity and know your customer and AML. I'm going to talk to you about that. And it's all about getting resilient. So we're using AI or we're teaching AI in the context of becoming resilient in your organization and finding things you could not before. So I'm going to talk a little bit about you about this this morning. If you look at the course on digital security and risk, there's a few angles to that. One angle is the whole track of how to look at the organizational risks and to see what kind of perspectives you have on that. That also comes with KYC and compliance issues, of course. I will go in that a little bit deeper later. And we use artificial intelligence to help mitigating those problems and mitigating those issues in your organization. This digital risks and security and risk, that's also about the area where you have to look in that artificial intelligence as security is not a technological IT problem, it's an organizational problem and moreover a business problem. So that's how we address AI problems in general. In a Rabobank, I'm residing at the compliance area where we use a lot of tooling, a limited set of tooling for kind of projects we use in our compliance fraud area. So fraud detection, we do anti-money laundering, we do CDD, KYC, we do some name screening, we do data quality checks, etc., etc., etc. What we use for that is a load of tooling, but mainly the main things we use is Inform Risk Shield and BigML. We do use some R, some Python, and of course Power BI, Power Apps, and Tableau to do some visualization. And if you talk about business engineering and getting your workflows right, we use BizIG. So nice things to look into either. There was a lot of talk already in the previous talk about the data wrangling and the data preparation. We do that at Rabobank with Inform Risk Shields to prepare our data streams. Most of the times we work with streaming data, meaning all transactions. That's approximately 10 million a day. We screen with those toolings. Some things we do in BigML as a machine learning platform. We do anomalies, we do false positive reductions, we do some fraud detection, we do KYC, we do classification of documents, we do data drift, we do default predictions, we do data drift. So we have BigML in place for many projects and many domains within the bank. It started all off with compliance and fraud and AML, but it's spreading spreading and spreading. What is that artificial intelligence? Because I'm going to talk a little bit about artificial intelligence. That is not only the work we see doing with Python or R. It's a much broader idea on bringing philosophy, psychology, neuroscience, biology, math, and sociology inside your organization. So if we design applications with machine learning for our domain, it's not only computer science, it's also about psychology and sociology. When we talk about fraud, it's not only looking at the data, it's also looking at the persons, at the context, at everything we can get our hands on. And why is it hard to apply it? It's hard to integrate seemingly this was a research from Deloitte from some years ago. It's hard to integrate cognitive projects or AI machine learning projects with existing processes and systems. And that's where we started. We started with Rabobank, and everything I teach is start off where you want to apply your AI, where you want to apply your machine learning, and make the platforms you use capable of executing that. And we teach executive management on machine learning and stuff like that, because I need managers to really understand cognitive technologies or machine learning or artificial intelligence. With Rabobank, we get piles of data. And Rabobank is one of the largest agri-financing companies in the world. So of course, we also look at a little bit at smart farming. And then you come into data like drone data, or data from crops, or data from cows. And I always like this. So this is a little bit what our customers are facing. We have data that's being used to create smart farming. But in our inside world, we only look at the financing. So we could support, I think that's a good idea to support our customers, farmers and agricultural business with machine learning and the lessons we learned. That's already taken on by Ed. Software has eaten the world, and we do eat software, because most of the software, if you really think deeply on that, is helping organizations to make better decisions. And that's the core of the thing. If we want to make a decision, if you look at farming, if you want to make a decision upon your cows and the needs they have, the way how to provide the best milk, then you need data. If you want your crops to grow, you need more data. But that data will form your software, and not anymore the engineers that create software for you. And of course, engineering of software is needed when it comes to integration, when it comes to screens. But even though somewhere in the early 2000s, we created some AI that generated screens, because if you have the data and you have a question, then you can generate a screen, no problem. But that's another way of thinking on what software is and how software can serve you as an organization or as a company. Today I'm going to elaborate a little bit on what we do in the fraud and KYC area. What it is, KYC, know your customer, coming from that nitty-gritty part of the bank. If you look at AI machine learning, how is that different from traditional programming? This is a section I made on what is programming without AI and what's programming with AI. I always encounter people that make programs without AI. They answer only one specific question. I want to generalize more. I do not want to find this fraud. I wanted to find a group of frauds. So you really have to think on why AI is different than your traditional programming language. And already talked about, what we are missing is the reasoning part. So intelligence is not only the machine learning, it's not only the um, learning from data. It has to do with linguistic intelligence. We can understand language. You can understand me, even though I'm not a native English speaker, but you can understand me. If I talk about a chair, you know, okay, that's probably something he's sitting on at the moment. Um, um, reasoning is something machines are not very good at the moment. So talking to BigML and Francesco, we talked about, okay, what we lack is that reasoning part and that kind of linguistic intelligence. And we get rather good at that learning part, but not as good at the other parts. So what we tend to call artificial intelligence is a little bit drilled down to machine learning, and we need a lot of work on the other areas. But we need to be open for developments on that. So let's take a little peek into the financial world, and this is what we do with our students too. MBA students come in. They come in ranging from financial officers to compliance officers to business people to salespeople. And with Nyenrode Business University, we try to get them on a higher level in a broad spectrum of things that are happening in the business world. And one of the things is digital security, which I think they need good understanding of and ask the good questions to the IT departments and machine learning and AI, because they need to ask the good questions and see the possibility and the potential of that for their business models. It's all about getting inside your organization and getting inside those areas in which things are not solved by automation or hardly solved, or there is a need for a different angle on a problem. Because if you look at the traditional ways of working, people will always find a way of more or less solve a problem. But okay, let's dive a little bit into the deep. Let's go to what I call the dark side. So there is a happy side of banking, the happy side of banking that 99.9999% of the payments and all the customers are okay customers and are okay payments. So that's not why we're looking into this. We're looking into this because there is a small fragment of our customer base. It's a small fragment of payments worldwide that has a, let's say, a questionable source or questionable destination. And that's where we have to look at. So our tasks are mostly very concrete. Money is being stolen, money is being laundered. If you look at the news, you look at laundromats, you look at things in the news that banks get fined because they do not look carefully enough, or drugs labs are being rolled up, etc. So that's what we're looking at. We call that financial economic crime, and KYC is a way of getting insight on your customer behavior. So we need to identify and verify this. Those are all processes we have to have in place. But my idea comes here, where we need to monitor how our customers are performing and understand the nature and objective of the customer. It's also an interesting angle, because if you look at the things artificial intelligence is not as good at this moment, is that reasoning and understanding part. So I'm looking forward to working on that specific aspect. And if you understand the nature and objective of the customer automatically, because we have over 10 million customers and you cannot know them all. So a famous organizational guru says you only know, can only know up to 50 to 100 people personally. And after that, it's gone. So we need too many people to staff the bank to know every customer by heart or in person. The controls we have and the things we do is monitor. That's what you do in cybersecurity. Yeah? You see what kind of things are hitting your organization. With financial economic crime, what money is leaving the bank or coming into the bank that has a doubtable source or the doubtable destination. That's what we're looking at. And as we are looking at, as I said, 10 million transactions a day, it's not that easy. It's not that easy because there's a lot of stuff going on. If you would alert 1% of your transactions, you would be in trouble. We talk a little bit about this in a RegTech. So if you look up in the internet, RegTech, the regular technology, you find all the aspects in what we're talking about: fraud prevention, regulatory compliance, compliance with data warehouse, case management, surveillance, employee surveillance. So this is all the areas where we are looking at as a bank and as our teams momentarily. Okay, look a little bit into the money laundering schemes. This is a money laundering scheme. You can pick that up from internet, for wherever. It's collecting of dirty money. That's always where it begins. You place it somewhere, you layer it, so you distribute it to some other banks, hiding the source of your funds, and then integrate it again, purchase luxury assets, goods, buildings, whatever. And this is what we're facing. So we're not knowing where the money comes from. We only see money coming in and out of the bank. And we see sometimes we see that it's being used to buy Bitcoins or luxury assets. So it's all about this. It's all about dirty money. It's all about dirty money. Anyway, if you talk about fraud or you talk about AML or KYC, and KYC is the solution, but if you look at financial economic crime, you look at dirty money somewhere. Okay, how to get, and that's where Nyenrode come in. Of course, you come in. Where do you obtain your criminal money? Now, one of the ways is to get do some cybercrime, or these are the doors of the Maastricht Dutch University. They were attacked by ransomware, and they could get free by paying, I think, 200,000 euros. So that's where the scheme starts. The scheme starts with dirty money. And it's hard. It's hard because, as you might imagine, that there is an information, let's say, asymmetry between people who do this and the banks who look at all the transactions. So they only have to look at a few things, and we have to look at everything. And the nice thing is that AI is the future. So machine learning, AI, reasoning is the future for cybersecurity, for better and for worse. The meaning that our attackers will use it too, and we will use it to defend it against attackers in some way. That's an interesting concept, and that we are not the only one using these machine learning tools, but the other side of the table does too. Then you have again some news some years ago. I think 2016, Ocean from Cambridge Analytica came in, where psychometrics came in. So when we look at data, we can also consider psychographics and psycho data from customers or behavioral patterns around us. Well, what we as Rabo, so this is a little bit of context. So what we did as Rabobank, we are really looking into an AI machine learning ecosystem where we have a co-creation with the business, we have customer data, partner data, we have all kinds of information inside and outside the bank, mostly inside the bank, that will guide us. Hey, what's happening with our customers and what's happening with our money flows? What in the previous presentation already came to the forefront is that data wrangling and collection of data is one of the most important things, and you will spend most of the time or a lot of the time on that. When we started fraud detection in 2008, we got a pattern because I teach also IT patterns. There is a pattern in IT that's called complex event processing. And I figured that is exactly what we try to do. We have a lot of channels, we have a lot of events. For example, our fraud system is fed by approximately 30 sources. So in contrary to a spreadsheet in which you can say, okay, I have this amount of rows and this amount of columns, we have a huge amount, but we need to structure that in a flowing way. So we have events coming in. We call everything an event. Every change in data is an event. Every payment is an event. Every login on a device is an event. Every change of a telephone number or an email address is an event. And we started in 2008 until now still reasoning about those events. Is it logical that this event follows this event? So if a change in an email address is being followed by a login on a new device, is that strange or not? And is the payment that comes out of that suspicious or not? That's what we reason about all day, or machines reason about all day. This is a little bit, if you break that complex event processing flow down, you come to something that looks a little bit like this, where I put in some products we use. We have, of course, all my transactions, my logs, my sensors, my historical data. We put it into our processing engines in Form, Reshield, and BigML to find us the frauds and find us the insights of not only from looking back, but being into the moment. And finding fraud and finding risks in customers. KYC for me is getting a good insight on my customer. If you look at me, I'm not a risky person. I only get a salary every month, and I almost spend it. I spend it probably almost everything at the end of the month, and then the beginning of the new month, and money coming in. That's my regular space. Customers like that are not very risky. Customers that like that could be fraud because there's a constant stream of money. So you have to look at it from perspective. Fraud and KYC are different perspectives on the same problem. We are experimenting. So to the left, there's a drawing we did with Francisco about AutoML, feature generation, feature selection, and model selection. A great thing. That's exactly what we wanted. When we talk about fraud, we talk about let's say if you talk about fraud, you think there are 5 features, and from, to, account, description, type of a thing, and then date, timestamp, something like that. But we build up in the architecture you just been shown approximately 2,000 features or transformations, whatever you want, from that. And our dream was to just, from that history we have on customers and payment behavior, get tens of thousands of features, and then make an auto selection on those features, and then do the machine learning. That's the thing that we do now with BigML, and that delivers better models. If you look at this picture, then without AutoML, we perform at 78, a phi coefficient of 7.78. If we look at it with the AutoML, we score a higher score into the 8s. So this is exactly why we are experimenting with how can we improve our modeling with using more capabilities of that automating machine learning process. And we look at a lot of data. We look really at a lot of data. We do not call, and I do not call it, tend to call it big data, because I still use very limited sets to learn from. If I, for example, it's the statisticians under us. This is the following problem we have. We have 10 million transactions a day, and let's reason about that. 50 of those are fraud. Then I have a totally screwed data set. There is nobody who can statistically prove that those 0.000% is so we have to drill down the data sets toward a reasonable sample of the normal group and the abnormal group. And with this this AutoML we did here, we used a PCA, we used anomaly detection to get us a good understanding of those data points. Other area, anomaly detection, my all-time favorite, because if you look at fraud, if you look at KYC and behavioral checking of customers, then you need to say, okay, I'm looking for things I never seen before. And that's an intriguing concept, that machines can find things it never saw before. And that's a helpful concept. That's a helpful concept to think on several aspects. I was teaching a while ago for some people from the Arabics, and they were in the oil drilling business, and they say, "I want to find the wells that are going to break down." And that's an interesting concept, huh? Drills of wells that are going to break down. Can you use supervised learning for that? That's a different one, because if you look at all the data from now, you can probably know that the new wells are doing okay, but you're not sure. So you need another way of looking at your data and finding patterns in that data that help you identifying the things you have to look at. So identifying it as a unsupervised learning problem instead of a supervised learning problem is helpful. That's also what we do with KYC, getting an insight on customer behavior. We collect a lot of data, but first, isolation forest. That's very interesting. 2017, I was put on that route by an academic colleague of mine and said, yeah, isolation forest could be the thing to look for. And BigML has implemented a version of isolation forest, and that works very well. We just did a perfect benchmark between all those things again with all academic data sets, and lo and behold, the isolation forest of BigML comes on top of the traditional isolation forest. That's already almost the best of this in the world. So we're just doing it because it's the best. We create some features for KYC. As I talked about fraud, we created approximately 1,000 features, 2,000 features. When we talk about KYC, we created plus 400 features. Why? Because we try to be very granular in finding how to formulate behavior of customers in features. These are, for example, cash features, number of cash deposits we look at. And then we have a, let's say, conceptual model KYC. Get some historical data, filter by peer group, do a peer group anomaly detector creation, and score the original data. And we get provable right results. So in the anomaly detection part, we have up to 70-80% true positives. Near a threshold we have still 20-25% true positives. So that's for a I don't know if there's people from the financial institutions here. 25% around the threshold true positive is very okay if you only have a limited set, and we will have a limited set of signals here. This is nice. I talked a little bit about you already about patterns. You need patterns to get insights on what you're doing, and you need a kind of language to understand what is happening. So I'm very glad. I'm super glad with the icons of BigML, because they help me in formulating workflows and formulating and visualizing my actions in machine learning in a way. And I hope BigML will come this year with a visual workflow engine, so you can do this almost drag and drop drag and drop line. This is what we do with our KYC and let's say risk detection or risk rating prediction, and we create explanations because we want to have analysts look at explained outcomes of the model. This is what we do. We have over 10 million customers. We build with risk shielders inform a profile in 1 hour. We do some wrangling with BigML in all those peer groups, and we create every weekend 63 million risk indicators. Most of them are none saying no risk, and some of them saying, hey, this is risky. And we had to do some metrics. We were into model validation. So if you come into the real business, then you also come into model validation, and you need some metrics. So we tried, and we have made some, and we can talk about offline. We can talk about some more metrics we created on this. But first, we saw, hey, is there proof of separation? Can the anomaly detector separate kind of normal customers from an abnormal customers? And yes, it can. If you look here at the gray area, the gray line, that's a normal mean for the whole population, and what's being flagged as an abnormal, as an anomaly, is the orange part. So it really by default can distinguish between let's say a general behavior and a deviant behavior, even though you never know again if it's fraudulent or not fraudulent. So creating ideas, this is another project we do on document classification. And again, you need a visual language to formulate your ideas in such a way you can communicate about them with other members of the team. And that's exactly what we try to do here. So what we do here is we have some data sets from 2 vendors. We split them up. We do some AutoML with a reference class. That's something I need to explain to. I think I have to explain that to Francisco, because I did some tweaking in the WSML script BigML delivered to have a reference class in for my prediction of work. And then we do the normal things like AutoML with association discovery, topic mining, topic modeling, clustering, let's say PCAs, and bring that data to a test and training set, and then try to learn from that and make fusion out of that. And this is a super cool way of working, and delivers surprisingly good results. Even so good that I start wondering, oh, am I leaking information here? And here, a crucial part in this picture is also the human assessment and sampling. Because if you do machine learning, you need a human in the loop somewhere that helps you better the training set and letting you being able to learn from the feedback from real humans. And that's super interesting. And talked a lot about BigML with about say anomaly detection with feedback, so semi-supervised learning. And you need some of these formulations to get good projects running. For general, if I talk to my students at Nyenrode, most of the time I end up with this, is that we live in a technology world, and it will change the way we work. We work inside organizations. COVID helps in changing and making things more digital. In our homes, in our personal sphere, AI and machine learning will take a larger role. And we have, as organizations, but also as universities, have a role to see how can we establish what I called digital trust and sane human-computer relationships. How can we do that? When we Enrique talked about technology in business universities, and when I started, my first idea for bringing AI into MBA courses was, I think, 2014. I said, no, yeah, no, that's not for us. That's too far away. That's too techy. But in the meantime, we started teaching it, and it's effective. And even our Master of Science classes on digital transformation, we do machine learning, because it's so important that people understand, and that managers and business understands what the power of that is, but also what the weaknesses are and what the things are. And we need to do it in a good way, so that machine learning, AI should be a strategic question, should be on that agenda, and of course make it safe, secure, meaningful, and fun. That's a little bit. And with BigML, I have a lot of fun, because I'm the only one who's having fun making models and presenting it to the business and seeing how quick we can create business value. And of course, you need to be educated. And this is Edgar Dijkstra, Dutch scientist. It says, yeah, you need to make it simple, but at the same time, you need a lot of education and insight to appreciate that simplicity. And most of the time, vendors try to make it complex because that sells better.